Thank you very much to the organizers to invite me to this impressive meeting. And when I listened to you talk, I thought how difficult inflammation in the intestinal tract really is. It's not as simple as in gout. And that means all the drugs that work in other diseases never work in inflammatory bowel disease. So I just want to show you that the incidence of autoimmune disorders over the last decades have dramatically increased. And this is not just a reporting bias, it's such as multiple sclerosis, asthma, type 1 diabetes, and what I'm going to talk about is Crohn's disease, inflammatory bowel disease. Why this is, we have a little bit, some hypothesis, I will tell you a little bit about it. But inflammatory bowel disease is a chronic inflammation of the intestinal tract that eventually leads to chronic destruction of the intestines and to permanent damage. There's Crohn's disease and ulcerative colitis, that's what we call it now, maybe names will change. I just want to show you again, those are different cities in Europe, how the incidence over the years of inflammatory bowel disease has definitely increased. Now, the pathogenesis, the pathophysiology of IBD is quite complex. Those are very classical polygenetic diseases, and it's sort of the poster child of these diseases because many genes have been identified through GWASs, and those genes are involved in specifically the pathophysiological inflammation. Sometimes you find genes, you don't know what to do with them, but here we found a lot of genes that are involved with inflammation, repair, and mucosal integrity. So this genetic predisposition is polygenic, many genes, it's not that easy, then leads to some immunoregulatory defect and also breach in epithelial barrier, possibly. That's your predisposition, and then once a so-called environmental trigger occurs, that could be anything, could be just a common tourista, you know, you go to India or in Switzerland, wherever, you get some inflammation in the gut and that will breach that barrier, and all of a sudden this interaction starts and the body cannot control the inflammation. It could be bacteria, it could be drugs, it could be anything. So that's our problem, that we don't know really where are we going to prevent this. Now, these are a couple of those Crohn's susceptibility genes I told you about. For instance, defensins, those are natural antimicrobial peptides. There are also those, we saw this before, there's pattern recognition receptors. They're involved in recognition of bacterial, the first response. Then a lot of genes that are involved in the orchestration of a secondary immune response. There are genes involved in the epithelial integrity. So a lot of work is going on here, and a lot of points of entry where people could. Then the autophagy system is very important also in regulation in the inflammation in Crohn's disease. So now we call the diseases by their names, ulcerative colitis, Crohn's disease, but they're probably a bag of diseases we don't really quite understand. And in the future, or we're working on it, a lot of more information on the pathophysiology and genetics will be generated, and we hope that we can actually name the diseases according to their genetic loci and to target the therapy accordingly to the pathogenesis. Now, why is the incidence of those autoimmune diseases, especially Crohn's disease, increasing over the years? And this one thought was, or is, this so-called hygiene hypothesis. So we're way too clean, right? So we know our body, or especially the immune system of the gut, is totally different from let's say, when you breach the skin, you get a different immune response than the intestinal immune system. It's a tolerizing immune system. And we're not exposed to those helminths and parasites anymore, so the intestinal immune system doesn't get educated all the time to be tolerant. Maybe our society could learn that. Now you see that the incidence of IBD is mostly, the highest incidence is definitely in the so-called Western civilized world where we're supposed to be clean. You're hard-pressed to find, really, in Central Africa, lots of IBD. But it's been shown that in the developing countries, such as Brazil or China, the incidence of IBD is increasing rapidly. Now, you have to imagine, that's probably why the inflammation is so difficult in the intestinal inflammation. We harbor about 10 to the 17th bacteria. That's even for you guys a high number in our body. That's about 10 times more than the entire sum of our cells. So we actually we guests to our bacteria. They outnumber us by 10 to 1. So when you have to think, only one layer of epithelium separates those bacteria from invasion into the tissue. So there's a constant fight and struggle and bickering between attacks and defense, and there's some good guys and bad guys, good bacteria, bad bacteria, and we don't know most of them. And this process is going on all the time, and you can imagine if a breach in this thin layer occurs, then we have a problem. The bacteria can enter, and then the first line of defense will start. The innate immune system, the macrophages, will then secrete all these cytokines, pro-inflammatory cytokines, recruit the T cells, and then B cells, antibodies. But also, very importantly, the regulatory cells need to come in, and this is the new paradigm over the last years, is the Th17, Th23, Th17 concept of the cells, the Tregs, the down-regulating of the immune system. You can kick it up, but you need to bring it down again, because then otherwise the permanent damage will occur. So there are lots of entry points, regulation. Now, if this balance is dysregulated and you have more pro-inflammatory signals, then that's when you have the permanent, the chronic inflammation, and you lose the tolerance against the bacteria, but also for an antigen. So you always bombarded, every day you eat with a lot of antigens, and they of themselves probably can cause more inflammation. Now, the interventions. The problem is we don't know really what the primary pathogenic event is. It could be, as I said, just a salmonella infection or whatever it is. But since we don't know that, probably the best thing to do is what we're trying to do right now is to control inflammation downstream. Now, this can be done, which is done now, to block pro-inflammatory cytokines, and the paradigm was the advent of the TNF-alpha blockers, which were initially like a miracle. But again, inflammation is a little bit more complicated. They work well. But also now IL-12, IL-23, IL-17 is not working that well as anticipated. For instance, interferon gamma, you would think that might work. It failed in clinical trials. Now, or the other thing is to deliver anti-inflammatory cytokines. There's much work being done on TGF-beta delivery, IL-10 delivery. IL-10 so far has mixed results. Or one can block inflammation by preventing the homing of leukocytes, blocking the recruitment to the vessel wall by interfering with the cell adhesion molecules and their receptors, thereby reducing leukocyte infiltration and gut inflammation. So that's the reduction of the inflammation. Other aspects of therapeutic intervention could be more generic or diverse, like and that's a big buzzword right now, the microbiome, like those many bacteria. And there's been a paper published that we actually, like blood types, AB, 0, that we have microbiome types. We all could be divided in 3 or 4 different microbiome types. That was shown across countries, races, geographical regions, sort of, and that may be something to see if the microbiome could be modulated just by giving some good bacteria, eating some good yogurt, right? And antibiotics have been used with moderate success. Then defensins, those are genetically evolutionary, very well controlled antimicrobial peptides. Then the barrier function, how can we seal that, like a layer on top of it for the bacteria to gain access, or then the inflammasome we've heard about to prevent tissue destruction. Now, I just want to finish here and say I came back from the DDW, that's the largest GI conference in America, and I saw one abstract on nanomedicine, and I wanted to share it with you. They did actually good work by using nanoparticles and loading them with siRNA. Those are short silencing RNA pieces, and they silenced CD98, which is one of the inflammatory pathway molecules, and actually fed those to mice, and they had less inflammation. Now, you see the targets, the intervention gap is large, and now I just want to give my last slide, and I want to give you some microparticles in food, or food for thought, because as you know that a lot of microparticles are used in common ingredients like as toothpaste, and especially titanium dioxide, and Professor Rogler from Zurich, University of Zurich, just showed at the DDW that those titanium microparticles do actually very much activate the inflammasome with IL-1 beta and IL-18, and we have to really think about this when using those nanoparticles in IBD. They may even be a curse and not a cure. Thank you.